Okay. So uh, like for two people like Mahesh and Tejaswini, you both know what is Kubernetes, and I hope you both are go through the previous records, right?
Oh, yes. Come on.
Yes.
Okay. So coming to Kubernetes, uh, two way we can install and configure Kubernetes. Anyone know?
Through CLI?
No, 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 no. We first of all, I will differentiate that two things. One is managed Kubernetes service. Managed by this is two way we can choose Kubernetes services. Okay. First one is managed Kubernetes service and self-hosted Kubernetes service. As per the requirement, we will choose corresponding service. Okay, which one we need to go. I mean, for our application deployment, then we can choose as per the requirement. Requirement means in the sense of uh, like the complexity of the application or small size application or medium size application or large scale application. So as per the requirement, we can choose corresponding one. For large scale and for large scale, we can go with the manager Kubernetes service, okay? Because this is much like purely the most parts managed by any cloud provider. So, for example, some examples of managed Kubernetes services is EKS. This is AWS managed service, managed Kubernetes service. Then AKS. This is Azure. Then GKE, Google Kubernetes Engine. This is managed by Google. Okay. So if we go with the managed service, then it is easy process. Like we can quickly configure an installation of, I mean, we will get the Kubernetes cluster. Then coming to self-hosted. So coming to self-hosted, we are the one who need to manage all the part. The part in the sense of like master part and worker part, right? So we need to I mean, we need to uh, install some components. I mean, from scratch, we need some servers, right? To installation of the Kubernetes. Coming this manager way, we didn't bother about that thing. We only choosing, I mean, how many nodes that we need. So we can choose the node count when installing the managed Kubernetes service. Then coming to self-hosted, we have servers, right? We have the servers, then we need to install the components. Like, for example, we need two servers, okay? So the first server we will make as master. master node. So this machine will be our master node. So this node have that components, right? Like etcd, API server, scheduler, controller, all the things that we will install on this server. Then the another machine we will make as worker node. Okay. So we need to install some components here. Then what will we do? We join this server to master node. So when we we can check with the kubectl command, kubectl get node, then it will show how many nodes are connected with this master node. Then we will deploy application to this worker node. Okay, this is worker and this is master. So these are the things we need to do when we are going with the self-hosted. Got it, all of you?
Yes.
Yes.
Okay. So today we will installing and configuring a self-hosted Kubernetes cluster. Okay. Anyone have any doubt?
No doubt.
So we are going to scratch from scratch. Okay. So what we need two servers. At least we need two servers. Okay. To make one as master and one as slave. I mean worker. And ensure that that machine have at least 2 GB RAM. Okay. Sorry, 2 virtual CPU and 4 GB RAM. 4 GB, I think 4 or 2 GB. 2 is fine. So specification. Two virtual CPU. Then we need to enable some ports for communication. Ports. Okay. Ports in the sense of like these are two machines, right? This is we make this machine as master and this is worker. So these machines need to talk each other. So the Kubernetes services, different services are there in Kubernetes, like API server, then kubelet. So many services are there. So each services we need to open some ports like for two like that, some ports there. So we need to open correspondingly in each machines to communicate. So the ports are You can see my AWS console, right?
Yes.
Okay. So you can see my screen. The ports. So these are the ports that we need to open. Got it, all of you. So coming to master node, you need to open port number 6443. This is for Kubernetes API server communication. So this port they will use for communicate with the API. Then these servers are these 1 to 7 for master node, okay, and these 1 to 4 for worker node. Then next port starting from 2379 to 2389. I think one port there, okay. Yes, 79 and 80. We are going to open for etcd server client API. This communication, okay, like etcd server client communication. Then 10250 port we have open for kubelet API connectivity. Then 2594 kube scheduler. These are different components in Kubernetes master node. Then once you, yes.
Tawfiq, is that a default TCP for all in a real-time environment? It's a common for everywhere.
Right. This is common. That
Okay.
ports, yeah.
Okay.
Then 2574 the kube control manager. Then TCP22 for remote SSH because we need to log into that machine. I mean, to installation of all of these. Then UDP 8472. This is cluster-wide network communication panel VXLN. This is for a internal network like creation of VLAN inside the Kubernetes. So we need different types of like network services there. Okay, like Calico. This is Funnel, similar like a Calico. So in this we will go with the Funnel, or we can install Calico. So this is for network communication. Okay, cluster-wide network communication. Port number 8472. Then coming to worker node, we need to open some ports for worker node. So same way we need to open 10250. This is for kubelet API. So here also we need to open that kubelet API. So this kubelet API, through the kubelet API, the worker node and master node communicate, okay? Because coming to each node, we install kubelet agents. So the agents talk with the master part, I mean the status of the machines and all the things talking with the kubelet API. Then TCP 3000 to 3000, sorry, 30,000 to 30,200, 2070 to something. These ports we need to open for node port services, okay? And the node port services means I will tell you. This I will tell you, okay? This is actually we are like we exposing these port like 2000 something ports we need to open in between these, okay? 30,000 and 32,000 or something. So these ports are actually for accessing our application, okay? And the service here we are using node port and not any cluster IP or load balancer here because we didn't configure load balancer for this lab. So we are going with the node port. So we can access application via the machine IP and the node port, okay? Node port, any open port that we will get from the Kubernetes cluster. Then TCP, this is for remote access. Then UDP cluster wide, these were same communication, like network communication. Okay. So what will you do? We need to open these ports, okay, and attach to corresponding machine. So in my case, I opened, I created a security group, okay, and opened this port. And when when I am creating the master node, then I will choose the corresponding security group. Attaching the security group to that machine. Same way for worker node. So going, to my security group, I will show you the ports like these. You can see the 1 and 2. Master node. This is a security group, okay. And
I
I
think
will,
you're not showing other system, other screen. I guess. Still, we can see that the
sorry,
TCP port. Okay.
worker. So in my case, I created 2 security group and enabled the ports. So this is my master node and this is my worker node, okay. I will show my master node. So open the master node, you can see here that ports, see 6443 enabled, 22 enabled, 8472 enabled, 10250 enabled, 257 enabled, and these enabled, 59 enabled. These are the ports we need, I mean, required for master part. Okay. Any doubt regarding open? This is a security group actually. Okay. First, I created a security group. That's all. First, I'm going to EC2 console and go to the security group. Then enable these ports. These all inbound ports. Okay. And one more port security group I configured, that is for worker part. See, coming to worker node, I enabled a 10.250 for kubelet communication. So this port communicate with the other machine port, okay, in case my work master part. Then not for node port, I enabled these ranges like from 30,000 to 32,767. And yeah, this is for the network communication and this is for SSH. So I successfully created 2 security group. Then I'm going with the creation of EC2. And choose Ubuntu version 22. I'm changing my machine type to T2 medium, okay. So when we choosing T2 medium, we will get 2 virtual CPU and 4 GB RAM. I think 4 GB RAM is uh like a good, coming to Kubernetes configuration, at least we need 4 GB RAM, okay. Otherwise our cluster will hang or it's not responded like that. So coming to the network part, okay, network settings. Here we can see the firewall security groups. So there are two options: create security group and select existing security group. In our case, we already created two security group, right? One for the master and one for the worker. So here what we are going, creation of master. So here, like coming to security group, we can
Your
choose.
voice is breaking up a little bit, but we heard that you made two security groups, one for the master, one for the worker.
Oh, give me a second. I placed my phone better place. I hope now it's clear, right?
Yes.
Yeah. So yes, one for the master and one for the worker. So here we can choose, like coming to the configuration of virtual machine. Here, like under the firewall security group, there is two options. One is create security group from, new. Then one is for select existing group. We already have two security group, right? So here we can choose select from the, select existing security group, and we need to choose the corresponding security group. We already created a security group for attaching master node.
Again, your voice is breaking up, sir.
Now it's clear. I'm all
Yes, but you might have to repeat a few sentences you said.
okay. I think you got the point, right? We already
Yeah,
created.
overall, we get the point. You have two security groups, one for master node, one for worker node, and
Yes,
you are using those two security groups to create your network.
yes. So while we creating that instance, we can attach the existing security group this way, like coming to security group and select existing security group, then drop down. So here we can see the master node and worker node. So the one, I think this one is for the master. So I attach that security group for this master machine. So that spots are enabled in this security group. So this way we are attaching the security group by creating machines. Okay. Anyone have any doubt? All are good, right?
Yep.
Okay, then in launch instance. For the same way, we need to install one more machine for worker part, right? So choosing the machine OS Ubuntu version 22, type changing to T2 medium. Public. Here we need to choose security group because we already have security group for the worker part. 2 is for worker. Okay. Launch. So we successfully created two machines and attached the security group. Open the required ports. Okay, both machines are successfully initiated. Sorry, it's initializing. Okay, leave it. First, we need to log into the master part. Okay, I mean master machine.
In the previous lesson, you had given on a Minikube, the master and worker were on the
Yes.
same computer. Now we are kind of growing up and making them on separate computers.
Don't compare this Kubernetes with that Minikube, because Minikube for test purpose, or it's a minimal version of Kubernetes. We didn't use that version for any application deployment. That is only for
Right.
development phase. Yes.
Or just learning about Kubernetes on one computer.
Right. That is for actually testing purpose. So we didn't bother about worker node in any other machines or like that, because we can install all the components inside a single machine, and like we can work as a real. We will get a console like Kubernetes console, and we can work on that for the test purpose or development phase. So I'm going to log in and connect. So there are some commands. Okay, so that command we are used for installation of some components for that. I mean for worker node. My voice is breaking again. I'm audible, right?
No, your voice is okay now.
Okay, fine.
Because I guess it's UDP packets, once in a while they get lost for voice.
Yes. So I'm first changing my mission name. Okay, now my mission name is root at master. Okay, see. And I'm going to update package manager. So same way I'm connecting with my, I think 205. Okay, will make us worker node. I accidentally log into the worker machine, and the name I change as worker, sorry, master. So I'm changing back. Okay, so this is our worker machine. See, because don't confuse these machines, because the ports that we open will, I mean, conflict. Okay. Then
You ran the bin bash command, so it opened up another bash cell,
no.
and
It's
that's what
fetching-
you're saying. Don't
fetching.
confuse these two machines.
It's fetching, actually, fetching the host name while we entering bin bash.
I couldn't hear what you said. Your voice got scrambled.
You mean the bin bash, right? The command bin bash. I'm audible, right? Hello?
Yeah, the bin bash, you gave the command. Yeah, you gave the command bin, like the command bash inside the bin locate folder.
Right. That is for getting the host name. see, I will show you, okay, once again for the master part. Sudo su host name CTL. This is a way we changing our machine name actually. Then we the command is host name CTL, then host name, then the name of the host name. So this is a command line tool. Host name CTL is a command line tool, and we provide a name worker. Sorry, master. See, as of now, that is not changing to master. So while we type the command bin bash, it will change. Got it. So we successfully configure two machine and change the host name, then install the application package manager, update the package manager, everything is good. Worker, and this is master, okay. So we have some script, okay, like show you. Now we successfully configured these two machines. Then we enable some ports, okay, like ports are enabled. Ports are enabled. Then what we will do is we have some commands that we need to perform in each node, okay, like master, and we need to push that code to worker. So what will happen? It will install some packages, some services in both machine. Then after that, actually, we are using one services for installation of the Kubernetes cluster. Okay, self-hosted. That name is KubeADM. KubeADM. Okay, this service will help us to create a Kubernetes service, self-hosted Kubernetes service. So what we'll do, we need to install the KubeADM as well in this. We include that command inside the our commands. Okay, so we install both machines. After that, we will get a join command. So we use the joining command in our master machine. Sorry, worker machine. We will get that command from the master machine, and we copy the command and put it in the worker machine. Okay, so this machine automatically that is actually agent. Okay, like a API code. So this machines know there is one machine that is master is waiting for my joining. So this machine automatically joining with the worker. Got it. Anyone have any doubt?
Can you repeat this part, please? I didn't get it.
We are installing self-hosted Kubernetes cluster with one service, KubeADM. Okay, this service will make easier our process, like creation of our cluster. This is our cluster. So we have some commands that we need to perform in both machine, like master machine and the worker machine. If we have one more worker machine, then we need to install. Perform the commands in that machine as well. Okay, this is worker 2 like that. 1, and this is our master machine. Then we will get a joining command. Okay, that is one command from the master machine after installation of our different commands. Okay. Then we will get a joining command. Joining command from the master machine. Then we need to copy the join command and paste it in worker node. So the worker node automatically join with the master part. Got it. Amol, now it's sorted out, right?
And which machine has the admin Cube
ADM.
ADM installed on it?
Yes, we installed KubeADM in both.
Oh, the same software is installed on both.
Yeah, right.
But KubeADM is not part of Kubernetes. It's a third party, another open source.
Right. Yes.
Yeah. But it synchronizes with itself across different machines because they're part of the same network.
Right.
How does it know that it's part of the same network?
You mean same VPC, right?
Yeah, same VPC is like the same network, right?
It's like a agent actually.
Agent.
So we install agent, we can install any machine, right? Like in the command, like we done Datadog lab, right? So easily we installing the agent and the machines knows there is one machines on board like that. I mean the Datadog console we can see easily.
Is it like a daemon?
It's a kind of API actually. A agent with the API.
Okay. So how many machines are in the VPC? It will be on all of them.
No.
I mean, you install on each one, but they'll know that they're on the same network.
Yes.
Okay.
In our case, we configure 2 machines and we attaching that worker part to master part. Anyone have any doubt? All are good, right?
Yeah.
So we are good to install the commands. Okay. So I have some lot of commands there. Okay, like I will show you. So we can make it as a script. Okay. So if we have more lines of commands, different commands for installation, some packages, some tools, services, then we didn't perform one by one. Okay, because we can make as a script. Okay. So how to make as a script? Anyone have any idea? Because we have some lot of commands there. So we didn't install one by one. Instead of that, we can use a script and
YAML file on
not
Kubernetes.
YAML actually. It's a like directly we install in Ubuntu machines like apt update, like apt upgrade, apt install, like service, like that commands. Two way we can install. One is manual way, right? It will take some time. If we have a lot of consider like we have a 50 lines of commands, then what will we do? We need to perform 50 times, right?
Make a script and run that script on each machine.
Yes. So what we will do? We need to create a script like nano. Then the file name like common. This will be the file name and .sh, right? So it will create a script file, right?
Fill
Hit
script,
enter.
yeah.
Then inside here we can paste the enter command. Okay. So in my case, I have a few commands for the installation. So I paste here. So these are my commands. Okay. So here we can see first we need to disable the SAP memory. So disable SAP. Then we create a .config file to load the modules to boot up. So it will create a file name .configuration. Then system param. Give me a second. Then system CTL required for startup persistence. Yes, this is for the IP table configuration inside our local machine, like the Ubuntu machine. So this is sudo ect system.d kubernetes.configuration file and creation of bridge networks. Okay. Then so these are the commands that we need to perform manually. Okay. If we didn't go with the script. Now we are included all the commands like inside a common.sh script, and we will run the script instead of typing all the things. Then yes, coming to installation of container. Okay. I mean, coming to Kubernetes, we need a container, right? Like Docker or any alternative container services. So here you can see we install CRI, container CRI runtime. Okay, so it will create a CRI for our Kubernetes. This is a container runtime tool for deploying application inside our Kubernetes. Finally, we can see that get update install kubelet the version 1.29. Then update again, update package manager install JQ system CTL kubelet. And finally, sudo CTL system CTL start kubelet. So how to run this script? Now we have the script, right? ls common.sh. We can run the script using this way. And before that, we need to make this script as executable. Okay, as of now, this script doesn't have any privileges. So changing the modification using chmod, then plus into then the file name. This way we will make any file executable. Okay. Then the file name is sh. Hit enter. Now you can see color change. See, now this is executable. Then we can use, we can run the script using this way. Any script we can run this way, // then the file name, common.sh, hit enter. So it will it will automatically run the different steps inside the script. So this is for the master part. Okay. So say similar way we need to perform same commands in worker node as well. So here I am creating common .sh. Then paste, save, exit, same commands, okay. Then make it executable plus the file name sh ls. Now we can run the script command. This is worker node, okay. .sh. See, the master part is done. So both done, right? For the worker also completed. So we need to perform some more commands like we need to perform some other commands in early master part, okay. So that is sudo kube abdm config image pull. This command will like pulling some images from kubeadm repository. Okay, you can see it's downloading and pulling from this registry like registry.ik8io kube APS server installed. I mean pulled, then config. These are the components of Kubernetes master part. Then scheduler, kubeproxy, core DNS, etcd, all pulled. Then we need to initialize with the kubeadm. Sudo kubeadm init. Here you can see, leave it, we'll show again. Okay. Remember that we are in master part, okay. For the worker part, I think everything is fine. We only run the common.sh script only in worker part. Then we are good. We only paste the join command after we get the join command from the master node. So one more thing we need to perform, like we need to create a directory, and that directory for keeping our Kubernetes config file, okay. So this is a command. So this will create a directory.home, then .cube, then it will copy etcd kubernetes admin.config to that newly created path. Then the changing our ownership. So that part is done. This is performing in the master part, okay. Remember that. Then everything is fine. Before that, I will create, install one more networking part in master node. That is for Calico, okay. And this is actually now we are 90% or 100% install the Kubernetes components in our master part. So now you can see I am performing a Kubernetes command like kubectl apply. Then the file name, here the file name is a HTTP path, okay. and it's pointing to a YAML file actually. See .yaml. This is for creation of internal network for Kubernetes. So you can see it's created. So our Kubernetes have a network connectivity and we use Calico. So most part done. Then we need a join command. As of now, our master node doesn't have any worker node. We can see kubectl get node. See, only master node here. This is the master mission, same mission. So what will we need? We need a command line. Sorry, a command to join our worker part to this master. So this is a command kubeadm token create print join command. Hit enter. We will get a join command. See kubeadm, then the local IP. See 83. Then the token, and there is a SSH like encrypted code there. Just to copy and paste here. I mean worker node. Hit enter. See, it's successfully connected with the master node. So again, I am coming here and get node. See, worker is joined 9 seconds ago. Got it, all of you. kubectl get node.
Can you let me back into the computer? My computer logged off somehow. It rebooted itself, so I'm on my phone. I want to get back through my laptop. If you can let me in through Zoom.
Okay, so what will I do? I'm out.
Yeah, you might. This says host has joined. We'll let you know you're here. You might see me trying to get in again on your Zoom.
Yes.
Um.
Yeah. Give me a second. Sorry, I didn't.
Oh, no problem. I'll leave this phone one.
Yeah, I accept your connection. Yes.
Hi, I'm back on the bigger screen. I can see better the commands.
So we here successfully created a Kubernetes cluster. Then we can check the Kubernetes components like Kubernetes kubectl command using kubectl command. Get pod. See, there is now pod in default namespace. Then kubectl get service. See the Kubernetes service. This is a default service within our Kubernetes cluster that is for Kubernetes. Then deployment. No resources found in default namespace. kubectl get namespace. These are the namespace, default namespace there. So our deployments, all the deployments that we perform will go to the default namespace. If we didn't mention any namespace within Kubernetes, otherwise we need to create a namespace and we pointing that namespace when we are going to deploy any application. So these are the common, default namespace as well for the master part. So for example, we can create namespace like kubectl create namespace short form ns, then the namespace name like test, hit enter. So see namespace test created. See, one more namespace created 8 seconds ago. Then we can simply like deploy some application. Okay, so and we can access the application via the node port. In our case, we use node port. Okay, instead of load balance or cluster IP. In this case, in this Kubernetes, we use node port, so that we enable the 30,000 to 32,000 something ports for accessing our application. So as of now, anyone have any doubt?
No.
All are good, right? So
Oh, yes, Tawfiq.
okay. So I am going to install Nginx, okay? Nginx and pointing to our like we have a namespace like test, right? So now I am going to install one application within the namespace. In our case, the namespace name is test. So we can easily kubectl create deployment. Now we are going to creating a deployment, okay, within Kubernetes cluster. The deployment name is Nginx. Then we need to provide the name, I mean image for the application. So image is equal to Nginx. So this image is openly available, okay, openly available in Docker Hub. So it will searching for the image Nginx. So easily it will get from the Docker Hub that image. Then we need to provide the namespace n -n, then the name of the namespace, that is test. Hit enter.